Hello everyone. In this tutorial, I'll show you how to test your smart contracts without needing to deploy them on the blockchain. This is a great way to save time and resources while ensuring your contract works perfectly. Let's get started. In the previous lesson, we created a simple counter contract, deployed it to the TON testnet, and interacted with it. Let's quickly review the code to refresh our memory. Variables. ID. This uniquely identifies the smart contract instance. Counter. This keeps track of the cumulative count, initialized to 0 and incremented by incoming messages. Initialization. The constructor takes one parameter, the identifier for the contract instance. Getter functions. We defined two functions to retrieve the counter and ID values. Handling incoming messages. A message type called add is used to increment the counter when received. The receive function handles this. In the deployment script, random ID generation. A random integer is generated to serve as a unique identifier for the contract. Transaction. A transaction is sent to deploy the contract with 0.05 TON coins. Confirmation. The deployment is confirmed once it's active on the blockchain. In the increment counter script, initialize contract. We open the deployed contract for interaction and retrieve the current counter value. Send increment transaction. A transaction is sent to the blockchain to increment the counter by 1. Loop. The script checks every 2 seconds for changes in the counter value, and once confirmed, the updated value is logged. Today, we'll test the contract without deploying it to the real blockchain. Create a new project. I'm copying the project from the previous lesson into a new folder called Lesson 3, but you can work within the same project if you prefer. Let's navigate to the Counter Project directory. Open the test script. Inside the test folder, you'll notice an error. It says an argument for ID was not provided. Let's fix that by initializing the counter value to 0. Define variables. We declare variables to store instances of the blockchain, deployer contract, and counter contract. Setup function before each test. Create a sandboxed blockchain environment. Deploy the counter contract with an initial value of 0. Open the contract for interaction. Retrieve a treasury contract used for funding transactions, and deploy the counter contract. Let's run our first test to verify deployment success. Command. Run npx blueprint test. Error. The test fails because an argument for ID was missing. Let's update the script and run it again. Success. After saving the changes, the deployment test passes successfully. Now, let's add more tests to our script. Increment test. Create a loop to perform multiple increments. Log each increment for visibility. Simulate multiple users by retrieving a different treasury contract for each increment. Fetch and log the counter value before and after each increment. Generate a random value for the increment and send a transaction to update the counter. Verify the final counter value equals the initial value plus the increment to ensure the contract functions correctly. Let's run the test. Command. Run npx blueprint test. Success. Both tests pass successfully, as seen in the logs. Our smart contract increments random values without any issues. That's it for today. Now, you can test your smart contracts without deploying them on the real blockchain. This method is faster, efficient, and saves resources. Thank you for watching. We hope this tutorial helped you understand how to test smart contracts efficiently. At RNAGA Technologies, we specialize in blockchain development, and we're here to help turn your ideas into reality. Whether you're looking to build a mini app or develop a full-scale decentralized solution, we've got you covered. Feel free to reach out to us for your next project, and let's make your dream app a reality. Don't forget to like, subscribe, and hit the bell icon to stay updated with more blockchain development tutorials. See you in the next video.